Hey y'all, so it's Friday. Welcome to Friday. Please get started on the do first. Okay, so here's the do first. Hopefully y'all have had some time to work on it. I definitely do want everyone to get a chance to do it before you watch the answer. I'm going to solve it now. So you have sphere A and sphere B. They're located, let's see, 4 times 10 to the negative 2 meters apart. So that's our R. 4 times 10 to the negative 2 meters. If sphere A has a charge of 4 times 10 to the negative 6 coulombs, that's Q1, and sphere B has a charge of negative, oh, this one was positive, okay, positive, negative. What happens with a positive and a negative? That's right, they attract. So negative 2 times 10 to the negative 6 coulombs. The question is, what is the magnitude of the force on sphere B? Okay, magnitude just means the amount of the force. So it means the electric force and the force on sphere B. Well, we only really know one formula for electric force. It's K Q1 Q2 over R squared, which in this case would be 9 times 10 to the 9 times 4 times 10 to the negative 6 times 2 times 10 to the negative 6. Notice I didn't put it in the negative. Divided by 4 times 10 to the negative 2, and then you square that. So again, just like I recommended to y'all yesterday, my recommendation is for you to multiply everything across the top and then everything across the bottom and then divide after. So 9 times 10 to the 9 times 4 times 10 to the negative 6 times 2 times 10 to the negative 6 is 0.72, and then divided by 4 times 10 to the negative 2 squared, which is 0.016. And I just want to remind everyone that before you can square it, you do have to put it in parentheses. Otherwise, the calculator will square the wrong thing. Because remember, calculators aren't smart. So 0.07, oh, it's 0.072. Thanks for the correction. 0.072 divided by 0.016 gives a result of 4.5. All right, and then what are the units here? What did we calculate? We calculated a force, so the force is equal to 4.5 newtons. And I want to address the second part of the question. What is the magnitude of the force on A, the magnitude of the force on B? Okay, well, here's the truth. A was a positive charge, B was a negative charge. So A was this positive charge, here's B, some negative charge. They are attracted to each other. A is attracted to B, and B is attracted to A. The force that A feels is 4.5 newtons. The force that B feels is 4.5 newtons. Okay, and this tracks Newton's third law. Equal forces, opposite directions. This one to the right, this one to the left. There we go. So here come the notes for today. We're going to learn the one method. It's actually something that we've talked about a little bit in the past. So the one method is something for manipulation. So let's look at the examples we're going to do. Like example, if there is an attractive force of 500 newtons between two charges, what will happen if the distance is halved? Well, you could go through and you could do a whole bunch of calculations, or you could do the one method to answer that question. So what is the one method? Go ahead and copy down these steps for the one method. All right, so here's our example. If there is an attractive force of 500 newtons between two charges, okay, well, here's the two charges. They each have a force on them of 500 newtons. What will happen if the distance is halved? So we're going to take them from this distance, their original distance, and then we're going to half that distance. Okay. Is that going to increase or decrease the force? First of all, well, I personally think it's going to increase it, but how much is it going to increase it? We're going to find out. Let's apply the one method. So let's write down the formula we're using. F equals KQ over R squared. Okay, which variable are we going to change? Well, the distance. Which variable is that? Well, that is R. How is it going to be changed? Well, R is going to be half of its original amount. Everything else is staying the same, so divided by 1/2. Don't forget to square it because it's R. K is not changing, so K is 1. Q1 is not changing, so Q1 is 1. And Q2 is not changing, so Q2 is 1. So 1 times 1 times 1 divided by 1/2 squared, which is 1 divided by 1/4, which is equal to 4. Something's wrong with my screen here. 4. So 4 times. Well, what's 4 times the original charge? Well, the original force, excuse me. 4 times the original force, which is 500, would be a force of 2,000 newtons. The old force was 500. You have the distance and you get a new force of 2,000. Okay. Well, let's go on to example 2. So example 2, if there's an attractive force of 500 newtons between two charges, what happens if the distance is doubled? So now we're going to take our distance and double it. Instead of making them closer, we will make them farther. Well, if making them closer increased the force, making them farther is probably going to decrease the force. Let's follow the one method. So which formula? Well, it's the same. F equals KQ1 Q2 over R squared. What is changing? R is changing. How is R changing? It's becoming twice as much as it originally was. So we're going to double the distance. So put that down there, 2, and then don't forget to square it. K is not changing. Q is not changing. The other Q is also not changing. So 1 times 1 times 1, which is 1, divided by 2 squared, which is 4. Well, that's 1/4. Well, 1/4 times the original force, which was 500, is 125 newtons. So wow, that made the force a lot smaller. Okay, last one. If there is an attractive force of 500 newtons between two charges, what will happen if the charge of one of the charges is flipped and doubled? Flipped. Well, that means it goes from either positive to negative or negative to positive. Either way, the other one's going to stay the same. So if it was attractive, now it will repel. Okay, so it's going to double the charge. So the charge will be doubled. So Q let's say Q1 becomes 2 times Q1. Well, F equals K Q1 Q2 over R squared. Is R changing? No, so R stays 1 squared. Is K changing? No, so K stays 1. Q1 is changing to 2, and the other charge isn't changing. It didn't say anything about changing the other charge. So 1 times 2 times 1 is 2 divided by 1 squared is 1 times 500 is now 1,000 newtons. So our new force will be 1,000 newtons, twice the original amount of 500, and instead of attractive, it will now be repelling. Okay, I hope that this seems simple enough to you. Hopefully you will get really good at this by practicing. Have fun practicing. Good luck, and have a good weekend. Oh, wait. Please don't turn off the video because I forgot you guys are taking an exit ticket at the end of class today.